This is the third case and also the last case of the method of undetermined coefficients. In this case, the non-homogeneous part is in the form of polynomial functions multiplied by an exponential function and multiplied by either a cosine or a sine functions. Okay. As you can see, in the first case, we only see polynomial functions. In the second case, we have exponential function added to it, multiplied by it. And on the third case, we have a cosine or sine functions multiplied by a polynomial functions and in exponential functions. So if your non-homogeneous part is in this form, then the solution for this type is, again, this is just the specific solution to the non-homogeneous part. It's going to be still t to the s, right? T to the s multiplied to bracket polynomial functions with the nth degree, exponential functions, cosine, plus the polynomial functions with different coefficients, same exponential function, and sine of beta t. Okay. Or again, in this case, s is, in this case, you will determine the value of s, and the maximum value of x is, in this case, it's just 1. And s will be equals to 1 if alpha and beta is a root of the characteristic equation. If alpha plus minus I beta is a root of the characteristic equation. Again, where do you find alpha? You find alpha in your g of t, alpha right here, right? And you find alpha here, and you find beta is right here, okay? Here's alpha and beta where you can find. All right, and if alpha plus I beta is a root of the characteristic equation, then s will be increased to 1. Otherwise, s will be 0. All right, let's do an example. So this example here, again, is a second order linear differential equations with constant coefficients and with g of t. Again, g of t in this case is combinations of two different functions. So let's call this is g of t again, and this is another function h of t. Okay, keep in mind that we need to find two specific solutions to these two types of functions, add them together in order to find the specific solution for the entire non-homogeneous part. First, always want to find the characteristic polynomial. Cp equals to r squared minus 3r minus 4 equals to 0. And then you have r minus 4 times r plus 1 equals to 0. So then you have r equals to 4 and r equals to negative 1. Okay. In this case, we do not have a complex root. We all have real roots. What does it mean? That means s will be 0. You only need to consider s to be 1 if you have a complex root, and also alpha and beta are parts of the complex root. No complex root. And we look at sine and cosine. That means s equals to 0, not 1, 0. Okay, so s equals to 0. That's a good sign. Then the next thing is you want to consider g of t first. Is negative a e to the t cosine of 2t. Okay. Well, in this case, as you can see that you want to find y, big Y1t is the specific solution to this part of the non-homogeneous part. So it should be, you have e to the t, you have cosine 2t, you have t equals to 0, s equals to 0, so this is going to be gone, and you still have the polynomial functions. And in this case, the polynomial functions is actually just negative a, and it's a polynomial functions with degree 0. So then you just need to have a0 here. Okay, and plus, again, you need to repeat this step, but with b0 to distinguish from a0, and then you still have e to the t, and you have sine of 2t. So this is going to be a1t. Okay, for a2t, when you have so h of t equals to sine of 2t, then you have y2t equals to, do you have e to the t? No. So that means alpha is 0. E to the 0 is 1. But do you still need to sine of 2t? That means you have 1 times sine of 2t. So this is still a polynomial functions with the degree of 0. So I still have to have, if a0, b0, I would like to have c0 cosine of 2t plus d0 sine of 2t. Okay. Well, the next step is I have to combine these two functions together to get my specific solutions to non-homogeneous part y, big Y of t equals to y1t plus y2t. And it's going to be equals to this function add to this functions. a0 et cosine 2t plus b0 et sine 2t plus c0 cosine 2t plus d0 sine of 2t. All right. Now I really want to simplify this a little bit. I would have e to the t the same, so I factor it out. I would have a0 cosine 2t plus b0 sine 2t. I cannot simplify this, so I just rewrite these two functions plus d0 sine of 2t. Okay. Then again, I want to find a y prime t. This is gonna be just using dot products here, et, derivative of et, and rewrite the second functions. And then you add to the derivative of the second function and multiply to et. So you still have e to the t. And the derivative of this is going to be negative 2 a0 sine of 2t and plus 2 beta b0 cosine of 2t. Okay. And then you want to find the derivative of these two functions is going to be minus 2 c0 sine of 2t plus 2 d0 cosine of 2t. So this is the first derivative, but again, I want to combine like term e to the t again. So I have cosine 2t, cosine 2t. What is the coefficients? I have a0 and I have 2b0. Okay. And then I have, moving on to the sine of 2t, I would have b0 and negative 2a0. Okay, so it's much nicer to combine this together, right? Close parenthesis, and again, minus 2c0 sine 2t plus 2d0 cosine 2t. Okay. So again, the next step is I want to find y double prime t. So it's gonna be, again, I'm gonna use the product rule, so it's just e to the t. Repeating this, So I want to have a bracket, so it will be more clear. Say cosine 2t a0 plus 2b0 plus sine 2t b0 minus 2a0. Okay, this is first, and then I would have then I need to add to again e to the t with the derivative of this function. So it's gonna be 2 negative 2 a0 plus 2b0 cosine become sine 2t. Okay, and then I would take derivative of this will be plus 2b0 minus 2a0 of cosine of 2t. Okay, so this is and again I find the derivative of this, which is negative sine would be cosine, right? Negative 2, negative 4, c0 cosine of 2t. Cosine would be negative, so negative 4 d0 sine of 2t. Oh my god, this is long. Okay. So, and then the next step is we have to plug y prime and y double prime into our original equation, right? And then try to solve for our undetermined coefficients a, b, c, d. So this should be y double prime minus 3y minus 4y, 3y prime minus 4y, and minus 3 is going to be negative 3 here, and it's going to be negative 4 here if you multiply all of them together, right? Well, I just did some scratch work because I ran out of space here. But when we plug y, y prime and y double prime into the original equation, the left-hand side will be equals to e to the t. Say you have cosine of 2t, and you have 8, negative 8, a0 minus 2, b0. Okay, and then you have the sine term, sine of 2t, multiply by negative 10, b0, plus 2, a0. Okay, so this is the term, the first term that involves e to the t. And then the second term right here. Okay, and the second one will be revolved. Will be the consequence of this functions will be cosine of 2t plus, I have a plus here, cosine of 2t negative 8 c0 minus 6 d0, okay, plus sine of 2t of negative 8 d0 minus 6 c0. Okay, and this is the left side after I plug everything in and simplify everything out. And then this is the left side here. You have to force this equals to the right side, right? Equals to negative 8 e to the t cosine of 2t plus sine of 2t. As you can see that on the right side, we only have e to the t and cosine of 2t. That means this terms here should be equals to 0, right? If this term equals to 0, that means negative 10 b0 plus 2a0 equals to 0. Okay. And then in this side, we don't have cosine of 2t itself. So cosine of 2t should go to 0 as well. That means 6 negative 8 c0 minus 6 d0 also equals to 0. All right, so we came up with two equations based on our observation. And the next one is, as you can see that e to the t cosine 2t here, and the coefficients has to be negative 8. That means negative 8 a0 minus 2b0 equals to negative 8. And the coefficients of sine 2t is 1. That means this whole coefficients here is going to be 1. 6 c0 equals to 1. This should be 0, not 8. Okay. So we found two systems of equations, and hopefully that we can solve for it. So, I mean, the goal should be simple now, right? We just solve for a0, b0, c0, d0, and we plug a0, b0, c0, d0 into our